Hi, everyone. Thanks for being here. I'm Emily Elias. I'm the director of the USDA Southwest Climate Hub. So we cover New Mexico, Arizona, Nevada, Utah, Hawaii, and the US affiliated islands west of Hawaii. And our main mission is to work with farmers, ranchers, and foresters on weather and climate adaptation. And so this is a perfect partnership with Quivaria and the new Agrarian program, and also with the Drought Learning Network, which is something I'll tell you a little bit about. But I wanted to let you know that we're going to record the presentations tonight so that we can post them. So if there's anything that you want to hear again, that'll be available. You can also always reach out to any of the presenters, and I'm sure they'll be glad to answer any questions you have. Also, as questions come up, please feel free to use the chat box. You can put any questions or any thought in there at any time during the presentations. And then we'll have a time in the agenda where we can really dive into some of those questions. So feel free to just use the chat box and share any of your thoughts or questions. So what are we going to do tonight? I'll briefly just give a little bit of background. And then Leah we'll have some time for introduction so we can all meet one another. And then Nancy Selover, who's the state climatologist for Arizona, will be talking about drought, aridity, and weather. She'll talk for about 20 minutes. And then Peter Goble, he's a climatologist with the Colorado Climate Office, will be talking about weather and climate tools useful for agriculture. And then we're really lucky. We have a lot of climatologists with us tonight. Then Steph McAfee will be leading the Q&A session, and she is the state climatologist for Nevada. So there's quite a lot of expertise on the call to talk with you about these things. And we also wanted to hear from you about your experience with drought. If there's any stories you'd like to share, any specific questions, we'll have time for that at that time. I wanted to briefly mention how this evolved. So Katie, Steph, and I are part of the Drought Learning Network, which is a group of resource managers and climate service providers that came together. This is our first year. We came together in person in February and decided that we could streamline and better provide some information and also listen a bit more. And so we came up with the Drought Learning Network along with about 40 other people. Now we're at 60 people. With the goals of fostering knowledge exchange between managers, so you, and climate service providers. Also to support the creation of some self-directed peer-to-peer learning networks, so people learning from each other about drought and extreme weather events. And then establishing structures that help us better respond to future drought. And so there are 6 working groups, and we are the Beginning Farmers and Ranchers Working Group, and we decided that we should start by just understanding and knowing who's already doing this work. And that's how we found Leah and Quivaria, and that's how this evolved. And I won't go through all the working groups tonight, so we have time. And then that's my last slide. So I'm going to stop sharing and turn it over to Leah.
Great. Thanks, Emily. So I think just to keep things brief, I'll just go around and call on everyone, and then hopefully we'll have plenty of time at the end for everyone to share what's going on your operations and ask any questions. But for now, if you want to just say your name, where you're located currently, and what type of operation you're on, and then also where did you come from before where you're at now at your apprenticeship. So Sam.
How's it going? I'm Sam Schmidt. I'm at San Juan Ranch in Saguache, Colorado in the San Luis Valley. We're a calf to finish grass-fed operation. It was where we came from before this position. That was the other. Mm-hmm. I worked at a grass finishing operation in New York.
Great. Thanks, Sam. Alex?
Alex, and I'm in Durango, Colorado at James Ranch Artisan Cheese right now. And then right before this, I came from the North Woods of Wisconsin, Ashland, Wisconsin, working on a vegetable CSA.
Great, thanks, Alex. Brady?
Hello, I'm Brady. I am in Drought, Montana here on the Moe Ranch. And we're just raising some cows to send into the great cow market out there, but we're doing a good job at it. And previously, I was the assistant farm manager down at Warren Wilson College farm in North Carolina. So this has been a cool transition for me.
Great, thanks, Brady. Jill?
I'm based out of Santa Fe. I'm the Southwest coordinator for the new Agrarian program. So I work for Quivaria part-time and then run a culinary garden for a restaurant in town.
Thanks, Jill. Dylan?
I'm Dylan Jones. I'm at Soul Ranch in Wagon Mountain, New Mexico, which we're a cow-calf operation, as well as a limited grass finishing and grass-fed beef sales operation when the grass and the market's allowing. And I'm coming from a diversified draft power CSA in Goble, California prior to this.
Thanks, Dylan. I see both Charlotte and Becca together.
Hey, I'm Charlotte. That's Becca. I'll let her do what she wants to do. We're in Chuchas, New Mexico, working at Tui Street. We are a plant propagation, tree grafting center / nursery, and our mentors also do a lot of key line design work. I'm coming from Boston, Massachusetts, where I was doing a lot of landscape work.
And before here, I was on a hog farm raising local meat in the East Mountains of New Mexico, making compost.
Thank you. Julia?
Hey, I'm Julia. I'm in Oregon House, California, Richards Ranch, and we do beef, pigs, sheep, and yeah, grass-fed. Yep. Oh, before this, I was in Virginia doing vegetable production.
Great, thanks, Julia. Natalie?
Hi, I'm Natalie. I am at the Milton Ranch in Roundup, Montana. I came from farming and outside of Great Falls, and then farming for 4 years in Gunnison, Colorado.
Great. Thanks, Natalie. Megan?
I'm Megan. I am in Big Sandy, Montana, working with on the Chevet Ranch, their cow-calf operation. And from before this, I came from working for some outfitters in Wyoming.
Great, thanks, Megan. Peter?
Hi, I'm Peter. I'm a researcher at the, oh shoot, there's more than one Peter.
Yep.
Okay.
Apprentice Peter.
Hi, I'm the other Peter. I am now at Enderlin Ranch in Big Timber, Montana, formerly of Seacross Ranch. And before that, I was in school and had been working on vegetable and berry farms.
Thanks, Peter. And Rex?
Yeah, hey, I'm Rex. I was also formerly at Seacross Ranch, and now I'm up here at Charter Ranch, which is just north of Billings, right now about 50 miles up here in the Bull Mountains. And we're on a cow-calf operation, and we're getting into kind of the direct marketing side of things, and we also do vermicast and worms. And before this, I was in Florida working on a golf course.
Thanks, Rex. And Tyler? Oh, not getting audio from you, Tyler.
Okay, I'm on Peter's screen.
Okay.
Yeah, so I'm Tyler Vandermark. I'm on the Enderlin Ranch as well in Big Timber. And yeah, before this, I was at school at Purdue University and doing some entomology research, I guess. And now I'm here. So
Great, thanks, Tyler. And then last but not least, Deanne and Dave.
Hi, Southwest Colorado, Norwood, on a chicken farm. And we have layers and broilers, and then we also do some vegetable gardening for a CSA. And before this, I was a cycling guide throughout the country.
Ditto. Great. And I think that is everyone.
Excellent. Thanks for being here. Any other things anybody wants to mention before we launch in? Okay, I'll turn it over to Katie Getz then.
Thanks, Emily. Really enjoyed hearing about everyone's backgrounds, and I'm interested to hear the questions that I'm sure tonight's presentations will generate. So we're going to get started with one of several climatologists on the call tonight. I am not one of those climatologists. I'm a policy analyst at the New Mexico Department of Agriculture and participating in the Drought Learning Network. Your first climatologist up tonight is Dr. Nancy Selover, and she's the state climatologist for Arizona. Her research focuses on the urban heat island, microclimate, and evaporation. Dr. Selover educates groups across the state on climate topics, including the monsoon, drought, extreme weather, climate change, and of course, Arizona's overall climate. She provides climate data and information to state and city agencies, private businesses, researchers, and the public. She serves on the statewide drought task force and the hazard mitigation planning team. One thing we learned about Dr. Selover today is that she teaches a meteorological instruments course at ASU, and she'll be teaching that very course in person to 5 students starting in just a couple of weeks. Dr. Selover?
Okay, thank you. Okay, I think I'm going to share my screen. Can you see my screen?
Not yet. Do you have the option?
Let's see. Share screen. Come on, share screen. Zoom. Let's go.
Sure.
Share screen. Share. Okay, there we go. All right. I assume we're there now.
Yes.
Yep.
Okay. All right. So I'm going to talk about drought, aridity, and weather, and I'm talking about what these things are and how they actually work. So first thing, desert versus drought. We're in the Southwest here in Arizona, New Mexico, and parts of certainly parts of California, Nevada, and Colorado are also tend to be Southwest deserts. So the desert is basically a place where the normal condition is where you have less precipitation than evaporation on an annual basis. When we look at drought, it's a different situation. It's essentially where you have drier than normal conditions. So you can have drought in a desert, and you can also certainly have drought in a very wet place. In a wet region like the East Coast, the Midwest, or the Gulf Coast, this could simply be a week without rain. In Atlanta, a week without rain is a major issue. In a place like Arizona, a week without rain is just a week without rain. In dry regions like the Western US, drought tends to be something that's cumulative. So it would be consecutive years with less than average rain. And this is essentially a cumulative effect. So types of drought, we have meteorological drought. This is simply that we have less precipitation than we would normally have for either a season or an entire year or multiple years. Agricultural drought is where we have lower than average precipitation, typically during the growing season, where precipitation is the primary water for crops, stock ponds, or for growth of rangeland vegetation or grasslands. Hydrologic drought is a reduced precipitation that results in reduced runoff into streams, reservoirs, or aquifers for water resources. So typically in the West, hydrologic drought is something that happens when we typically have drier than normal winters, because we tend to depend on winter snowpack to provide runoff and water for our summer and our growing season. Then of course we have socioeconomic drought. So that's anytime you have a reduced water supply, that's going to impact how people live, either how they recreate, tourism, it could be industry, it could be economic activity or social well-being. So if we have a drier than normal winter and the ski resorts don't have enough snow to open, that's certainly a socioeconomic impact of drought. Or for example, Lakes Mead or Powell, we're now in a situation where those lake levels have dropped so far that at some point they got to where the boat ramps didn't actually get a boat to the water. And so they had to extend the boat ramps by several hundred feet in some cases in order for you to be able to get your boat down into the water in order to recreate on the lakes. So we have short-term drought versus long-term drought. So short-term drought is typically a drier than normal season, and that will result in some significant reduction in vegetation growth, rangeland grass or forage. Or we can have a dry spring or summer that results in dead vegetation or increased brush fire risk. Long-term drought is something that we look to more in the West than they look to in the East, because typically they have frequent precipitation events throughout the course of the year. We tend not to have that when we're in our significant drought periods. So it would be consecutive dry years that give us reduced water resources, low stream flow, low reservoir levels, or stressed forests, which is certainly can lead to major forest fires. Here in Arizona, we were about 6 years into our drought before anybody in the state wanted to use the D word. God forbid we should call it drought, because people might not want to come to Arizona if they thought we were in a drought. We were in a drought, but nobody wanted to call it that. So we have arid and semi-arid regions. So an arid or a semi-arid region is a place where you typically have more evaporation than precipitation. So it's not just desert, but it's an arid place. And then you have the entire western United States that actually qualifies as arid or semi-arid. And the only exception to that are the highest elevations. So when we look at a map of the United States annual precipitation, the normals for the past 30-year period, we see that basically the western half of the country is looking at 24 or less inches of liquid water per year, and the exceptions, of course, being the higher mountain ranges throughout the West. And so we really are a dry place, and we'll talk about why right now. So circulation in the United States. So this is where we get into the weather part. So circulation is all our weather comes from the West, and for the most part, certainly through in most parts of the U.S. all year, and for Arizona, it's 3 seasons of the year. We have westerly winds, and that brings our weather in from the Pacific Ocean. So we have this thing called the jet stream, and essentially this is a high altitude little highway of very fast moving air. Typically the jet stream divides the colder air to the north from warmer air to the south. So in this case, we're seeing this jet stream pattern where we have it going over a ridge of high pressure and going underneath a trough of low pressure. What you want to notice here is that air moves counterclockwise around low pressure and it moves clockwise around high pressure, and that's going to be important when we get to our monsoon. So the thing that happens about the jet stream is storm systems, fall, winter, and spring storm systems in the U.S. tend to move along the path of the jet stream. So wherever this jet stream sets up, that tends to be where the storms are going to go. So in this case, we would see the storm coming out of the Aleutians, which is typical, comes down the coast and enters the U.S. along the California-Oregon border, up into Idaho, Montana, and then down through Nebraska and off into the southeast, and then off into the Atlantic. In that situation, this part of the country down here, the Southwest, would be dry and warm. The storm would not provide us with precipitation, snow or rain, and it would also not bring cold air because cold air is staying on the north side of the jet stream. The eastern side of the U.S., the northeast, is going to be very, very cold, and so this is sort of a typical path. The other thing that's critical to this whole thing about why are we dry in the West and not so much in the East and the Midwest is where's the source of water. So this is the atmospheric moisture source. And so when you're in the East Coast, you have the Gulf Stream current, which is coming from the Caribbean, which is very, very warm water, goes up the East Coast. Warm water is continually mixing with cooler water and it's losing some of its heat. But even all the way up to New Jersey, New York, and off the coast of Massachusetts, that water can be relatively warm. And in the Western United States, we have a cold current. So the water along the West Coast is going from the pole down toward the equator. And so it's very cold water. It's mixing with warmer water and it's generally losing some of that coldness. But even as far south as San Diego, we really have cold water off the coast of California. If you've ever gone to San Diego into the water, you know that it's quite cold water. So until we get down off the coast of Baja and the Gulf of California, we don't really get warm water. And the importance of this is that all these places that have warm water, water evaporates very readily. And so we have a lot of atmospheric moisture available to provide rain or snow or hail or all the other kinds of things that fall as precipitation from the sky. Where we have cold water, we don't have a lot of moisture because it's very difficult to evaporate cold water. So we have a limited amount of moisture in the atmosphere to provide rain or snow. And the reason that we have most rain or snow over the higher elevations is because as that moist air rises, as limited as the moisture is, the colder you get in the atmosphere, the less the atmosphere is able to hold it as vapor and it condenses into clouds. And so over the higher elevations is where we tend to have clouds. That's where we're going to tend to have the precipitation. So when I look at a winter circulation pattern, I have a couple options shown here. The one where we have the jet stream further to the north up here is time when the southwestern part of the U.S. is going to be relatively dry because the storms are going to stay way north of us. So Idaho, Montana, Wyoming, the northern tier of states are going to tend to get those winter storms, and they'll be nice and snowy. But down in the southwest, we're going to be relatively warm and dry. And this is the typical pattern that we see during our drought years in the southwest. The pattern down here, where the jet stream dips down, this is what we see in our typical wet years. Or in our normal years, we'll see kind of a mix of both of these. Our last two winters in the southwest have been pretty wet, and so this has kind of been the pattern that we've seen. So the storm systems come on down here, they cross into Southern California through Arizona, New Mexico, and then head off toward the east. And so that's been our situation the past couple of winters. Summertime, everything changes. Summertime circulation pattern, the jet stream moves up into Canada. Sometimes it doesn't go that far north. Sometimes it just stays over the northern tier of states. It seems to be kind of what's going on a little bit this year. But for the Southwest, none of those things are in play anymore. And so all of our weather, the monsoon, comes from this circulation. So this high pressure right here that's typically sitting way over here off the East Coast migrates its way across and sets up over Texas, New Mexico, or the Four Corners. And remember I said air goes clockwise around high pressure. So that high pressure circulation sitting here draws this warm, moist air up from Mexico and the Gulf of California, and that's providing the moisture that gives us our monsoon in New Mexico and Arizona and parts of Colorado as well. How far north it goes doesn't always get all the way up into Colorado. Sometimes it goes quite a ways into Colorado. California stays dry because California is dependent on this pattern of the jet stream, and the monsoon the high almost never moves far enough to the west to provide much summertime precipitation. Every once in a while, they'll get a hurricane, a tropical storm from off the coast of Mexico that will provide some summertime precipitation. But generally, California is just a dry summer, and that's the Mediterranean climate that's typical of that area. So here's some water balances. And so the first one here is Phoenix. And so this is water year 2019. And so these blue columns that you see are rain events. Okay, and so if you look across for this water year, see, we didn't have very many rain events. We had quite a few right at the beginning in October and early November, and then not much that particular winter. and then a little bit by the time we got to summer. So this was really a dry summer. So the summer is in here. But what you should also notice is we have year-round evaporation. So it's always evaporating and it's occasionally raining. And so this was actually one of our wetter years. In the Phoenix area, we got almost 10 inches of rain. That wasn't too bad. But we had 45 inches of evaporation, which means we ended up with 35 inches of water going up rather than coming down. And so that's basically the reason we do irrigation here, obviously, in order to grow things. It's a little bit better when you move into northern Arizona because you get higher elevations. But down in the Phoenix area, we're certainly the Southwest desert. New Mexico is a similar situation, but this is Santa Fe, this particular location, so it's in the mountains. They tend to get more winter precipitation. So you can see the winter, they don't have much evaporation at all, but they have precipitation, and so they've gained water. And then come summer, they tend not to have quite so many rain events, but they have lots of evaporation. And so basically you see it, all that water is being lost, and you end up with, at the end of the year, with a net loss. Again, irrigation is a necessary thing. We move up to California. So California has some winter events, and so they have a pretty good winter. This is Oroville area, so it's Northern California. And so you got a lot of winter precipitation up there because you're just off of the Sierra Nevada. But then by the time you get down to summer, you're seeing less and less of that precipitation. And through this part of the summer, it's completely dry. So essentially, you're just heading down all the way. And this particular year, they did okay. They came out with a net gain of 4 inches or so, 4.5 inches of water. Colorado has another situation where we have a lot of precipitation in the snow. This is Black Forest, so this is near just north of Colorado Springs. And so we have a lot of winter precipitation, so we're gaining. But then summer came, and even though there was some precipitation events, there was huge amounts of evaporation. This isn't in the mountains. This is off in the eastern side of Colorado, so it tends to be drier. And so they ended up just squeaking out a little positive value in their precipitation. So we moved to Montana. Montana is a little different situation. So again, you tend to have winter precipitation events without any evaporation. But in the summertime, even though there's evaporation, they also tend to have precipitation events a little bit more frequently. And so Montana does a little bit better in terms of grasslands and filling stock ponds and things like that than some of the other states. Summer rain. So these are just maps of summer, graphs of summer precipitation, June through September for each of these states. And this is the location if you want to go grab this. There's certain cities that you can grab this information for as well. You can certainly grab it for different counties and different climate divisions. So these are just statewide averages. Again, California has a dry summer, so 1.22 inches is their long-term average. And so some of these states have more than that. But the other thing I want you to notice is that you can't depend on it. It's highly variable, and you have to look carefully at the scale to see how variable it is. This looks like it's extremely variable, so you can go from 1/2 inch to maybe 1.5 inches or 2. Which doesn't seem like a lot, but considering that the place typically has a dry summer, it is quite a bit of variability. Certainly in Arizona and New Mexico, we get quite a bit of variability. Something that you always have to bear in mind because you can't just depend on, oh yeah, well we typically get rain in the summer or we don't typically get rain in the summer. Every year is going to be different. This is a look at the weekly drought monitor starting with the 3rd of March, and we can go through and see how drought has changed in the West. And so we're still at a little bit of late snow things, and then we stop that late snow, and now we start going into the dry period in the West where the summer is really not kicked in. The monsoon has not kicked in. The Southeast, of course, is losing some of their drought because they typically have lots of storms, hurricanes come through and things. But when we look at the West, it just typically gets worse and worse into the summer. And the only time this is going to see improvement is when the monsoon kicks in and we start getting activity. The drought map that's going to come out tomorrow has all of this in Arizona as moderate drought, this tan color, because we just have not had any activity yet so far in the monsoon. So it's going to look even worse tomorrow's map than it does today. But they don't put it out till tomorrow, so I couldn't really grab it. So there wasn't much I could do about that. So this is another way to look at it, and these data and these graphs are available from the Drought Monitor, which is, here's the URL for that. And so you can look at back to 2000 when they started the Drought Monitor. Every week's value is in here, and you can see what percentage of the state, and I think you can do this by climate division as well. This just happens to be by the whole state. What percentage of it was in drought and when they came out of drought, you know, so Montana was having issues way back in 2002 to 2005. And then it's come out, and at this point in time, they're not in too bad of a condition. Colorado, similar situation early on, but it's still very different than what goes on in Montana because of the where that jet stream is and how that precipitation happens. So California, this is where, of course, they had their worst drought back in the 2012 or 2013 to 2017 period, and then Arizona and New Mexico. So you can go look at these for any place that you want, any of the states, and I think you can do it by county or climate division as well, so you can get a finer tune to where you happen to be to kind of see where have you been. You can also get those precipitation maps to see what's it been in the past in the location that you're at. As we look forward, this is, I don't know if this is good news or bad news, it's just kind of news. This is the previous fourth National Climate Assessment expectation or projection of the change in seasonal precipitation by the end of the century compared to this period from 76 to 2005. This particular one is the worst or the highest emissions scenario. So assuming there's maximum CO2 being emitted. Thing to note here is that the stippling, basically the red dot areas, are places where the anthropogenic change or the emissions impacts are expected to exceed what the natural variability is. The places that are hashed with the little diagonal lines are places where the natural variability is much more important than the anthropogenic change. And so for a lot of us, what's going on down here in the Southwest, the natural variability is much exceeding what's going on with the emissions. Up in the northern states, that's not necessarily the case, particularly in winter. And a bit in the spring as well. And so some of these are saying, you know, plus or minus 10%. So it'll be, this is one of those, in the winter, they don't know if Arizona and New Mexico are going to be wetter or drier than what they were before. And so there's a lot of, you know, there's a lot of iffy things about the models, but it's their best estimate of where we can be. The only thing I know about Arizona is that, in the Southwest, is that every year you have a really good chance of having a really dry year, or you have an equally good chance of having a wet year. At the moment, we're in our 25th year of drought, so I'm not anticipating a really wet year. This coming one is they're actually anticipating it could become a La Nina situation, which would be good for Idaho and Montana, not so great for the southwestern states and the southern tier of states. Anyway, so there's sort of little ideas about where they're predicting it's going to be for each state. And I think that is my last slide. Yes.
Thank you, Nancy. I saw some good questions being popped into the chat box, so I imagine those will continue, and we'll move on with another presentation and then open it up to all manner of Q&A. So our next presenter is going to be Peter Bennett Goble. And let me pull up his bio right quick. Peter Goble is a research associate with the Colorado Climate Center. The center is located at Colorado State University, where, as a graduate student, his research focused on the role of soil moisture in seasonal weather prediction. Now Peter's work is primarily related to drought, climate, and land-atmosphere interactions. Recently, he's been working to develop crop-specific indicators of drought severity. He's Colorado State Coordinator for the Community Collaborative Rain, Hail, and Snow Network, better known as COCO-RAS, and that's the nationwide effort to share the weather that falls in your own backyard. He enjoys participating in education and outreach events where possible, so he was a good get for tonight. Peter?
Hi, yeah, thanks for having me. Let me see, I'll share my screen real quick here. And if things go right, you should see, are you seeing the just Zoom screen?
Yes.
Yes.
Perfect. That is what we want. So now when I show my slideshow, it'll go over to my other screen. Let's see here. All right, and then I'm going to set a timer for myself so I don't get too long-winded. But again, thanks for having me on. I really appreciated learning about all your backgrounds. I just want to say I really respect what you all are doing, pursuing a career in farming and ranching. It's, you know, crucial to our economy and our sustainability. And it's hard work. I talked to a rancher not too long ago that was saying that he worked a half-time job because he's out in the field 12 hours a day, so he's literally working half of the time. So hopefully, even though I'm not a farmer or rancher myself, some of the information that we provide here will be helpful to you. What I'm hoping to do today, and let's see, my slide didn't advance there, did it? Okay, let's see. Okay, there we go. What I'm hoping to do today is just give you a few links to a few different tools that you can use for weather and climate information that may help you make decisions along the way. And what I've done is I've organized it roughly by what time scale you're looking at, whether you're looking at information for this afternoon, tomorrow, 1 to 7 days, or out a season, or years from now. When we get into the seasonal stuff, I'll add a little bit to what Nancy said about the monsoon, but not much. She did a great job covering it. And then I want to talk a little bit about the El Niño Southern Oscillation, or ENSO. I saw there was a question in the chat about that, and I'll talk about some of the seasonal variability that it brings. And then I'll talk a little bit about climate change and where you can get information on that. This is, so my first slide is just looking at a resource you can use for looking at weather data for a given afternoon. If you see clouds and you're wondering what might be dangerous, I would say download the Radar Scope app if you get the chance. It's just a app that you can download for free on your phone that'll show you where the storms are or how they're moving. I think that's really crucial as a farmer or rancher, is that you have a good sense of what's going on with the thunderstorms around you, so you can stay safe. So if you zone out for the next 18 minutes but download Radar Scope, you got something out of it that improved your life. I'm happy with that, but hopefully we can stick together a little longer than that. One statistic that I've included here is men are more than 7 times more likely to get struck by lightning than women. I don't know if that means we're 7 times stupider. That's certainly the case in my household, maybe not everywhere. So now we'll move into what does the weather look like tomorrow. Most of you probably already have a favorite source for this, so I'm not going to spend a lot of time on it. It's what we best know of when we think about gathering weather data or forecast information. I guess the thing that I maybe would enlighten folks about is that I think it doesn't matter a great deal, you know, what news channel you're looking at or what website. I like weather.gov. They're basically all building their forecasts around the same numerical models that are, you know, built using the same satellite, weather balloon, and surface weather station data. So hard to go too right or wrong in that way. One tool that I really like for looking at upcoming rainfall across the area is the Weather Prediction Center's Quantitative Precipitation Forecast, or QPF. I've provided a link here, but on the right-hand side of the page, what we're looking at is an example of a 7-day precipitation forecast in inches. So you can see, for instance, in eastern New Mexico and parts of south central Colorado, a good week of precipitation was forecasted, but for much of the West, we're looking pretty dry. This updates every 6 hours and gets input from multiple forecast models, so it can be fun to watch. One thing I'll say about this, particularly in summer, is expect the totals that actually fall to be more sporadic than what you see here, particularly with the thunderstorms that we get this time of year. Things can vary quite a bit over just several miles or even less than that. All right, so I'm going to talk quite a bit about seasonal planning, and I'll introduce you to some resources from the NOAA's Climate Prediction Center. NOAA is the National Oceanic and Atmospheric Administration. But one thing that I do want to look at as well before we get into that is these seasonal prediction products focus on how things will deviate from normal. So as Nancy was mentioning, it's important to be in touch with what's normal for your area. And she showed the same precipitation graphic that shows average precipitation across the country, but these are good things to be in tune with when you're settling on a place to farm or ranch long term. Once you have been at your site for a few years, you'll understand things about the climate at your field or ranch that not even us climatologists understand, because you'll understand all the microclimates that go with it as well. But when you're settling on a location, it's good to know what's normal for the area. And this is where I've highlighted the PRISM Climate Explorer tool. URL is in that first bullet point there. This shows an example for, I believe it's Western New Mexico, where we're looking at average precipitation month over month. And in this case, you can see the influence of the monsoon, where lots of our lower elevations in the Southwest anyway will see a maxima in precipitation this time of year. As Nancy was mentioning, the jet stream moves north and we get a shift where we get more moist air in from the Eastern Pacific and Gulf of Mexico. All right, so now I'm going to introduce some of these Climate Prediction Center products. You can find all of these at the URL. They're listed in the third bullet point. But if you're planning more long-term looking at weather information, these can be useful products. What we're showing here is on the left-hand side, we're looking at a 6 to 10 day temperature outlook. And on the right side, we're looking at a 6 to 10 day precipitation outlook. Starting with the temperature outlook, the blue shading means there's an increased probability of below normal temperatures over that time frame. The warm color shading indicates increased probability of warm or warmer than normal temperatures, and then the gray shading indicates increased probability of normal. On the right-hand side, same thing for precipitation. It's just the brown shading is for below normal precipitation. The green shading is for above normal precipitation. The hue of that shading, or how pronounced it is, or how saturated it is, determines the extent to which that probability is true. For instance, the deep blue here indicates that there is at least a 60% chance that the temperatures over this time will be in the upper tercile or upper third of all years, or sorry, lower third of all years, since it's below normal. Similarly, I think we see 50 for the above normal. And then let's see, they make these same graphics, but for seasonal forecasts. So these are examples for August, September, October. They were issued the middle of July. As you can see, we're looking at an increased chance of above normal temperatures across much of the Southwest, and looking at an increased chance of below normal precipitation over some of the West US as well. One thing that you'll notice for the precipitation map is there's quite a bit of area shaded white with this EC label. That means equal chances of above and below normal precipitation. We refer to this as equally clueless. So I will say that seasonal forecasting, it is at a point where it does leave quite a bit of skill to be desired. Oftentimes you can't hedge your bet as much as you'd like one way or the other, but particularly in summer, expect living in the Western US to see more of these forecasts leaning towards the above normal range, as we can get a fair amount of skill just from the trend toward warmer temperatures that we're seeing. Okay, this is a product that goes along with seasonal forecasting called GrassCast that I really like. So what we're looking at here for the high plains, and unfortunately it doesn't work as well west of the Continental Divide, is a forecast for by the end of August, or the end of sort of that rangeland season, how will your grassland productivity look compared to a normal year? So what GrassCast does is it gives you 3 scenarios. This is an example of the low scenario. I'll get into that in a bit more detail, but it gives you a low, medium, and high precipitation scenario for the rest of the growing season. And it's basically tacking that on to what we've already seen throughout the season. So here we're looking at a forecast that was made at the end of July for if August has below normal precipitation. And as we can see, if we had a below normal August on top of what was already a below normal season for much of eastern Wyoming, Colorado, and New Mexico, we can expect our forage yields to basically be at least 15% below what a normal year would be, in many cases more than 30% below normal. Here is the same thing, but for the above normal scenario, where we can see that basically, given the hole that we're in already in eastern New Mexico and Colorado and Wyoming, we're unlikely to make that up. However, if you look at somewhere like, let's take northern South Dakota, for instance, we just went back to the below normal scenario, compare that to the above normal scenario, we see where August can still really make or break things. So I think this GrassCast tool is a really useful one for those who are in the ranching industry. When it comes to seasonal outlooks, I would say beware the Farmer's Almanac. It is fun, but it's not a scientific tool with any real physical guidance going into it. Basically, what it's doing is it's giving you a description of the normal climate for each region of the US in a flowery way. For instance, if you look at the north central US, yeah, winter is usually frigid and snowy, and you can probably make that argument even if temperatures are above normal and precipitation is below normal. Similarly, if you looked at somewhere like the Southeast, yeah, even in a mild winter, you might describe it as brisk and wet. The closest thing we have to something that we can analyze as a forecast is this normal precipitation on the West Coast. You'll notice it says polar coaster winter ahead. What is a polar coaster anyway? I looked it up in the American Meteorological Society glossary. Nothing came up. So Nancy already covered the monsoon pretty well. This is the time of year in which the jet stream, as she was saying, tends to recede north, and then the hot summer sun beats down on the desert southwest, and that area tends to warm up more rapidly than areas around it, creating what we'd call a thermal low pressure. It's sort of similar to if you think about if you put a cast iron skillet with nothing in it on a burner and put your hand on it, that'll burn you a lot more quickly than if you put a pot of water on a burner and stuck your hand in it. Just per unit energy, the rocks and sand will heat up much more quickly than, say, the waters of the Pacific Ocean or the Gulf of Mexico. So what that thermal low ends up doing is, in concert with the high pressure over areas further east, usher in these corridors of moist air, and that tends to be the wet season in the southwest US. What I will say is it's a transient feature, or another way of saying that is it's not clockwork. It's not like Old Faithful. Sometimes this will let you down. It's coupled with so many other things around that are going on in the atmosphere around the globe. And so sometimes, like in 2019, we called it the non-soon because there was so little precipitation. Weather Service offices in the Southwest usually do a good job tracking these things and providing data for it. I've linked to one example that I believe I found through the Tucson Weather Service. Yeah, that would make sense with the TWC there. But you can use that link to track what's going on with the monsoon. El Niño, or the El Niño Southern Oscillation. Maybe you've seen the SNL sketch where Chris Farley plays the wrestler that goes by El Niño. That's Spanish for the Niño. It's actually Spanish for little boy or the Christ child. It was discovered by Catholic fishing villages off of the coast of Ecuador, and it tends to show up around Christmas. Basically, what happens is when typical wind circulations break down along the tropical Pacific, the eastern Pacific waters tend to warm and change where thunderstorms over much of the equatorial Pacific happen. As it turns out, these thunderstorms have a lot of energy in them and have ripple effects around the globe. including ripples that affect the jet stream that Nancy talked about. And it turns out some of these ripples are somewhat statistically predictable. And here's a look at how these ripples kind of shake out around the globe. So in El Nino years, if you focus on the US, we tend to see conditions lean warmer over the northern portion of our western states, but wetter and cooler over the southern portion of our western states, particularly in winter and spring. And then in La Nina, this sort of reverses, where we see warmer, drier in the southwest and cooler up north. I noticed some of you were in Colorado, like me. We're in what I'd call more the ENSO neutral zone, where it tends to explain less of the variance in year-to-year temperature and precipitation over the cold season. Some of the more reliable things in Colorado are the northern Rockies tend to be wetter during La Nina winters, and the eastern plains and southern portion of the state tend to be wetter during El Nino springs. Another thing that we see around here is that El Nino years tend to be more boom or bust, whereas La Nina years are more consistent, like fewer smaller storms, whereas El Nino is more consistent to bringing in the kind of low pressure systems that will give us big precipitation across the entire state. Here's a link to an ENSO forecasting site, and the graphic on the right-hand side is showing the probability of La Nina neutral conditions and El Nino conditions by season. We're right now neutral, leaning La Nina, with things going more and more La Nina. So SON here, these bars indicate what's most likely for September, October, and November. It looks like there's just above a 50% chance of La Nina for this fall, and that stays consistent through the early winter, and then our predictability drops off a bit because we go further out into the late winter and early spring. But the thing that we can say more certainly right now is El Nino unlikely for winter 2020-2021. So I'll just do a couple slides on climate change. It's certainly been mentioned by both Nancy and I. I get a lot of questions about it, and one of the more common questions is, you know, meteorologists get weather wrong all the time. Why should we trust them for 50 years from now? And it's a fair question, but I will say, don't trust anybody who's trying to tell you what the weather on a given day or any month is going to be 50 years from now. We just know that we're placing more heat trapping gases in the atmosphere, and so we know that in general things are going to lean warmer, that being the case. The analogy that I think I like most is, it's kind of like if we think about Barry Bonds during the steroid era of baseball. You know, Barry Bonds is a great athlete. He would have hit a lot of home runs either way, most likely, but we're pretty sure that given years of steroid use, he is going to hit more than he otherwise would. In this analogy, the heat trapping gases are kind of like the steroids, where, you know, without them, there's going to be hot years, there's going to be cool years, there's going to be wet years, there's going to be dry years. Just knowing that, say, Bonds is on steroids doesn't mean that we can tell anything about a given at-bat, but we can probably say something about the season, or particularly his career. So Nancy mentioned the National Climate Assessment, I think, in her talk. I've linked to it here at the bottom. It's a good research, or it's a good resource rather, that's thoroughly researched for how climate change is expected to affect different regions across the US. Another thing that I just wanted to mention here, we're looking at a trend in summertime temperatures over the Southwest region, so June through August. We can see it's going up, but I do also want to mention that we don't think that it's going to continue to go up just because that's what it's been doing. It's not just an extrapolation. It's based on the impact of those heat trapping gases that are increasing in concentration in the atmosphere first and foremost. All right, I've left myself almost no time to talk about the US Drought Monitor. This thing may become a thorn in your side at some point if you're a rancher, because it has become tied to policy. where the categories of D2, D3, and D4 can be tied to disaster relief via the livestock forage program. It was started as just a research project to appraise drought using one map based on percentiles or how often we would expect things to be that dry. As Nancy mentioned in her talk, there are multiple kinds of drought. I like this quote from the late Dr. Kelly Redmond that says, in essence, as with rainbows, everyone experiences their own drought. It's very true. There's not just multiple types of drought, but it affects different regions differently and different operations differently. It's a very multifaceted hazard. So you can imagine just building one map to say this is drought is a tricky thing to do. If you at any point are frustrated with this map and feel like it doesn't represent your area well, there are places that you can submit impact reports to talk about how things are going on your farm or rangeland, and I've linked to that below. I would say the Drought Monitor's complexity, it builds in a menagerie of different indicators, more than I can count, is both a strength and weakness. The fact that it's complex means a lot of care goes into it, and an overly simplistic view of drought isn't necessarily ideal. However, with it being tied to policy, that's also a criticism that it can be a bit of a black box. Anyway, that feels like a bit of a tangent at this point. I'll close with this. I think that making good relationships with your state climatologist or even your regional climate hub can be a very positive thing. Like I said, we all love sharing weather and climate information. It's what we talk about all the time, and we have a vested interest in your success. So I'll just close with that, and I've got a link to each of our respective climate pages. I noticed that a number of you are actually in Montana. I was thinking more Southwest, but in Montana, you also have a great climate center. Dr. Kelsey Genso does a great job as well. So I'll wrap it up there, and I don't know how we want to do questions, but thanks so much for your time.
That's a perfect way to wrap up, Peter. Thank you very much, and also thanks again, Nancy, for your presentation. We've seen some questions being dropped into the chat, and we have the good fortune of having a third climatologist on the call tonight who's actually moderating. So it's not typical that a moderator would get an introduction, but I think it's worth knowing who's behind the keyboard, as it were. So Steph McAfee is the Nevada State Climatologist, and she's also an associate professor in geography and extension at the University of Nevada, Reno. And she's an applied climatologist who works on a broad range of topics, even dabbling a little in ag meteorology. So we've got three different scientists, and probably even more than that we could bounce questions off of. So I'll turn it over to Steph to pick up on the chat.
All right, thanks. So I noticed we have questions in the chat that we haven't gotten to yet, and I guess I think I might actually point some of these back to people where they came up to. But I'm actually going to start with I believe it was Alex's question about air moving counterclockwise around lows and clockwise around highs. And Nancy, I don't know if you want to take a stab at this. I usually do it with a video in class. So.
Okay, sure. When we have a high pressure area, basically it's because we have sinking air. So the air sinks down, hits the surface, it kind of bunches up at the surface and makes high pressure. When it hits the surface, it spreads out in all directions. Now, because the Earth spins, the air is actually deflected to the right in the northern hemisphere. And so for high pressure, that makes the air tend to want to go clockwise around the high pressure. A low pressure system is where we have rising air. As the air rises, it kind of leaves a vacuum behind, or a low pressure area, and that draws air in at the surface in to fill up that vacuum. And again, as that air moves in, it's deflected to the right, and that tends to make it move counterclockwise around a low pressure system.
Thank you.
All right. So I think there was also a little bit of back and forth about the evapotranspiration and how it can be more than the precipitation. And I don't know if either Nancy or Peter, either one of you wants to talk about how those values are derived, Because I was thinking one thing that becomes really useful here is knowing how that evapotranspiration is calculated when you're irrigating, if you're thinking about calculating irrigation amounts to put on your crops.
Well, the evaporation values that we were showing is basically potential evaporation. So that's the evaporation if you have a water body. That would be what's coming out of your swimming pool or your lake. Actually, you make an adjustment for that kind of a water body, but it's if you have enough water. So if you have standing water because you're irrigating, like in Arizona, we do flood irrigation, so you have standing water, you're going to get significant evaporation for all those days that that water's there. Other than that, it's going to be trying to draw moisture out of the soil, and it's going to be drawing moisture out of your vegetation. So it's not going to actually be that much water that leaves because the soil isn't readily going to give up that much water as a standing water body might do that. So it's really potential. It's not actual evapotranspiration unless you actually have enough water.
Thanks, Nancy. I saw that question in the chat, and I wanted to make sure I didn't say anything too much because I didn't know for certain if what you were showing with Phoenix was indeed potential evapotranspiration, but that definitely makes sense. Another way you can think about kind of an arid region versus not arid region is arid regions are what we call moisture limited, where you get a certain amount of energy that's being used to evaporate or transpire water out of the soil based on how warm it is and how much sunshine you get. The areas that are arid are moisture limited, where basically the actual evaporation won't reach its potential. There's just not enough water there. It's just you evaporate what you get. And then areas like, say, Vermont would be more energy limited, or there's plenty of moisture in the soil to go around, but you're ultimately, your evaporation is constrained by how warm it gets and how much sunshine you get.
Okay, and I wanted to point out as well that so this network CocoRAS was brought up, and this is basically a volunteer weather observing observation. People, you can go online and sign up, and you get the basic setup is just a simple plastic rain gauge. And so if you're in Colorado, it sounds like you email Peter and say, hey, I want to join. How do I get started? But some of those sites you can also measure ET, or evapotranspiration. And there's some relatively simple equipment you can use to measure that as well.
And that's where those graphs came from. Those were all from CocoRAS stations.
Yeah, please do email me. We'd be happy to have you.
And I was like, so every state has a CocoRAS coordinator. So we had a bunch of people in, Nancy, is it Dave in New Mexico?
Yes.
Okay, so if you're in New Mexico and you think this is something you want to check out first, you can go check it out online, cocoras.org. Then if you decide this is something you want to do, then you get in touch with Dave Dubois and he can get you started on that process.
Or you can also just hit the join button on the website.
Yes.
Yes.
Let's see. So I had some other questions up here. So now, following on the line of ET, so in the case, this is a question from Sam, in the case of net negative seasonal moisture, does that point to active desertification?
So I guess I would say that active desertification would be if you notice over the course of years and even decades that your water balance is getting worse. That would be what would point to active desertification. So you could have one year that's really net negative, and then the next year be, average or somewhat positive, like maybe we would see in Nebraska in 2012 and then 2013. That would just be year-to-year variability. But I think we actually have seen some of in the Southwest over the last several decades, those water balance averages seem to be ticking downwards, which would point to desertification.
And you would expect to see areas that had been grasslands are just not recovering as grasslands. When next rain starts, you're not seeing that grassland recover. It is just remaining barren ground.
Yeah, and so you may see as well, there's starting to be some talk among scientists and also in the newspapers about what people are calling aridification, which is, I think, maybe just a less scary way of talking about desertification. And this is really tied to those places where temperatures are getting warmer year after year after year, where it's actually just shifting into a more arid kind of climate than places used to have.
Yeah, one question I get from the media a lot in Colorado when we're in drought is this drought or is it aridification? Sometimes my answer to that question is just yes, where, for instance, if you look at Southwest Colorado, we've seen a lot of natural variability in precipitation that has generally not gone Southwest Colorado's way in recent years, but there's nothing necessarily in climate models or a very weak signal in climate models to suggest that that is the future. However, warmer temperatures, there is a strong signal in climate models to suggest that that's the future. So you kind of have a tandem effect there.
Okay. And we seem now to be flipping to the other side to flooding. We have a question. In areas that are predicted to have higher likelihoods of increased precipitation, are there flood monitors similar to those for the drought monitor? So Emily has posted the USGS flood information site. But this is also, I will say this is also usually information you will be able to get from your weather forecast.
Yeah, how much flooding you're gonna get at any point in time is dependent on a number of things. How long is the storm gonna hang out, and what kind of terrain or topography have you got? So in Arizona, we have flash flooding that is can be kind of devastating, except for it's over in an hour. And so the floodwater may last a couple hours, but it's not like what goes on in the Missouri Basin or places like that where they have flooding and it goes on for months. In the West, it tends to be relatively short-lived and not be a long-term thing. But of course, in the higher terrain, it can be quite devastating, as certainly they've noticed in Colorado, which is the reason that CoCoRaHS exists, so that we can monitor how much precipitation we get in order to generate those kind of flood events.
You know, and I will also say, once you get settled into an area and stay there for a long time, you will also get used to the sort of seasonal patterns of when floods are likely and what kind of floods you get at different times of the year. So I'm here on the west side of Nevada. We're right on the west side of the Sierra. We get floods basically every spring. A lot of you in Colorado will experience the same sort of thing. If you get a string of warm days in the spring, that snowpack starts to melt out and you can get a lot of water coming down creeks and rivers. So you'll kind of get used to keeping an eye out for, this is a time of year when flooding is likely. These are the conditions in my area that are conducive to flooding. So this is when I should be keying into that weather forecast, whether it's from the National Weather Service or, any TV weather forecast.
Yeah, I would mostly agree with that for Colorado. Certainly our stream flows tend to be highest during the snowmelt season, like May into June. I've noticed that some folks tend to get, I'd say, a little bit overly squeamish about the prospect of flooding based just on snowmelt or warmer temperatures kicking in. There are some places where that can happen, but that's actually not very widespread in Colorado. The bigger flooding threat in the spring for us is when we get a big rain event on top of already melting snow. That'll melt it much more quickly than just warm temperatures. The other thing is, like Nancy mentioned, this time of year, when we get a really concentrated thunderstorm in a canyon that's not moving, that'll create a flood really rapidly. In fact, in some canyons, we have signs that aren't jokes that say, in case of flood, climb to safety.
So continuing on this theme of increased precipitation, I have a question from Natalie, that a rancher recently mentioned that he was increasing the amount of rainfall by increasing the amount of plant cover on the soil, leading to increased ET, and whether this is a real response. So I don't know, kind of wants to take that.
I can speak to that a little bit. One thing that I know has been studied in western Nebraska, for instance, is that even though temperatures are getting warmer in general, there's been an increase in irrigated acreage for things like corn. Did I say eastern or western? I'm talking about western Nebraska. There's been an increase in acreage of irrigated corn and other irrigated crops. And like I mentioned earlier, the sun's energy tends to, in the summer, either go into just heating up the surface or evaporating things. And so if you have more irrigated acreage, more of that energy is going to go into evaporation. And so for, I think, western Nebraska, we've actually seen a decrease in the amount of 100-degree days because of the way that energy balance has changed. So I know at least on a regional level, or especially a local level, sometimes land use changes can either enhance or mitigate the impacts of climate change.
It also depends on is the moisture source for your storms a local source. So for us here in Arizona, our moisture comes up from Mexico. It doesn't come from here. So we're completely surrounded. We used to be completely surrounded by irrigated agriculture, which is now becoming urban. But we didn't have more storms then because of that, because that moisture evaporates, it goes up in the atmosphere and the wind blows it away. And so we end up with dry sky, dry atmosphere above us. And so we don't benefit from that evaporated water coming down as rain. It rains someplace else. So for us, our source of moisture isn't local. And for some places like Nebraska, it may very well be local. In the summertime, it's just convective and it all just comes from the surface as it evaporates. I don't know. Different regions have different issues with where the moisture source is.
Yeah, so it's...
Yeah, I would also say, oh, sorry.
Oh, no, go ahead, Peter.
I would also say, back to the original question asking about if you irrigate more acreage, will that lead to, in turn, more precipitation? I think that the more irrigation to more precipitation effect would have to be, it could be physically somewhat real, but there would definitely be a limit to how much you could expect that to work. Nancy, I thought of this thinking about Nancy talking about that moisture blowing away from them. The extra evaporation experienced from those irrigated acres is likely to fall somewhere else. It's going to get whisked off by the wind and fall who knows where.
Yeah, so it sounds like really you might have some local effects or not, depending. But it also sounds like we had a request for a verbal question, just because it's kind of long, hard to type into the chat. So I think that was you, Rex. So why don't you just go ahead, unmute yourself and ask that.
Yeah, thank you. So this is a question kind of about water cycling. And at the last ranch I was at, I always thought about with the irrigation that we did with pivots and stuff. So we're pulling out of a creek right on the property and irrigating, I don't know how many gallons per minute, but a lot of water. And say I always thought about if you irrigate the land, you're pouring all the water into the land right there in the same local spot it pretty much comes from. And then you don't hay it, but you let your cows graze that. So it hasn't dried up yet. Do you really count that as water loss? Like, I'm just trying to think of the location of water and how it moves. Would you consider that water staying in the same spot? Pretty much if the grass is still wet and the cows are eating it and then they're digesting the water and all the nutrients in it and returning it right back to the soil right there, would you consider that not necessarily pulling water from the creek and losing it to the environment? Or do you think that you could consider it the water is kind of staying local? I don't know if that makes sense at all, but Yeah.
So Nancy, if either you or Peter have a good answer to this, I actually do have a response to this one. So
well, I'll let you jump in. My
I'll defer to
first
you.
thought is it's local, but go ahead.
Okay, so I would actually say that, right, part of this is in fact going to kind of stay local, right? Because, of course, you know, as you're growing that grass, some of the water is going to be lost to the atmosphere, right? As you're growing grass, just some of that is going to transpire out of the grass, right? And it may stay local, it may blow away, right? Per the conversation we just had. Now, obviously, some of the water that's going into the grass that's then going into the cow is also going to stay in the area, right? You know, anything the cow's leaving around, that water's going back. Now, when the water leaves is when you go to sell that cow, right?
Yeah, that's what I thought about.
And there are a bunch of people who study this. It's called virtual water. And so we can actually trace how water moves from place to place, not as water anymore, but as agricultural production, as livestock, as even things like pants. And we think about this a lot in Nevada because we grow a lot of alfalfa, and the alfalfa then gets shipped out of state to feed cattle elsewhere. And we think it's funny because Nevada's the driest state in the country, and we essentially ship water as alfalfa to much, much wetter places.
Yeah, that's a way better answer than I would
So
give.
Is there kind of a general scale on, say, a pound of beef equals X amount of gallons of water?
There are. I don't know them off the top of my head. You could look them up because you can go online and actually calculate your own personal water footprint, right? On the basis of.
And you call this virtual water?
Yeah, people call it virtual water. I think sometimes it's called embedded water.
Okay, cool. Well, good answer.
There's a Wikipedia page on it if you Google it.
Okay.
We're having water shipped to Saudi Arabia. They bought 700,000 acres of land in southeastern Arizona. They're growing alfalfa, and they're pumping out of the aquifer tons and tons and tons of water, growing alfalfa and shipping the alfalfa back to Saudi Arabia to feed whatever it is they feed back there.
Wow.
I don't know why they allowed it, but that's what's going on.
Saudi Arabia owns 750,000 acres of America?
In Arizona, yeah, sure. Oh, there's huge corporate farms from foreign countries doing that, and they're doing it specifically to use our water because they don't have the water to do it themselves.
Another piece, another answer to that question, as the hydrologist on the call, I will say that yes, there's certainly the virtual water component, and that's going to be a part of the water that's put on the field, but there will certainly be interflow and infiltration that's either shallow groundwater or deeper groundwater percolation, depending on your system, and evapotranspiration. So not 100% of that water is going to be going to your virtual water. It's you need to think about the hydrologic balance and the hydrologic cycle. So some of it will go to virtual water, but some will also go other places.
Right.
Yeah, and I will just follow up. We certainly see here as well where we have irrigation ditches, right? And you know, you lose water out the sides of the irrigation ditch if it's not paved or you know lined in some way. And it turns out that is actually a really important source of water for a lot of local streams because you do have these connections under the ground where water is moving around. So we'll see where people will go ahead, line their irrigation ditch, and then the nearby stream is not as full as it used to be.
Well, thank you for your explanations. Appreciate it.
So is there any, so I've been trying to stay on top of this, but did I miss anyone's question?
So I see one from Katie that I wanted to address about, you know, if she understood correctly, the Kokorosk State Coordinator will ship you a free gauge. Unfortunately, that's not always the case. Some states do have programs that allow them to ship some free gauges. I would say it doesn't necessarily hurt to ask, but the way to get your rain gauge is to go to weatheryourway.com. I can put a link in the chat below, but it costs $40 or something like that. That's the only real startup cost other than if you need something to mount the gauge on. So it's still a pretty cheap endeavor, but unfortunately that's not given away for free. The ET measuring tool is certainly not free. That is, I want to say it runs about $200.
That's correct.
Yeah.
Yeah, so the other piece, the other measuring tool that may be of use for some of you in snowier areas is a snowboard. And that is actually, it is a relatively low-tech way of measuring snow. It is a white painted square of plywood and a measuring stick. They're surprisingly robust. Mine has been sitting outside for 4 years. I'm up high enough in elevation. We can get snow any month of the year, so I never get to put it away. And I believe you can get the measuring sticks on Weather Your Way, and I just put the web address in the chat. You're on your own for the plywood and the paint.
Steph, I see that we have just about 5 minutes left. Are there any last minute questions that anybody wants to get in? You can just unmute yourself if you have a last question before we close out. Okay, then I wanted to mention that if you click on your chat box, there are 3 little dots to the right at the bottom. You can click on those and download the entire chat to your computer. So I'm going to do that myself. So I have all the questions you asked as well. I will say also regarding Kokorosk, the Southwest Climate Hub often does supply rain gauges if somebody is really interested in doing that. So you can reach out through your Southwest coordinator if you happen to be in one of our states, and we can supply one of those Kokorosk gauges. I wanted to thank Nancy and Peter and Katie and Steph for helping facilitate this tonight. And thanks to all of you for showing up and listening and having these great questions. If you have any more, feel free to reach out through Leah or reach out to any of us directly. And I also wanted to mention, I'll put it in the chat box, we have a quarterly Climate Hub bulletin. So if you want to be abreast of things like this coming up in the future, I'm going to put that in here for you. You can sign up for those. They're only quarterly, so we don't try to send them out too much. And we just started a podcast. It's called Come Rain or Shine. The first podcast talks about atmospheric rivers. The second one is about the Sustainable Southwest Beef Project, and one is about precision ranching. So we have 3 podcasts out there. I'll put those in the chat box for you as well. And then the last thing, my last mention, is that if you're interested in GrassCast, the tool that was mentioned before, there's going to be an hour-long presentation on GrassCast. So if you want to know more about it, a little bit more in-depth information, that's on August 18th. And make sure I'm sending this to everyone. So here's the podcast, and here's the sign-up link for GrassCast. So this is the last one. August 18th from 4 to 5. It will be recorded as well. So if you want to watch it later, if you have other things to do, you can watch that later as well. So that's it for me. I think, Katie, did you have a last thing you wanted to mention?
I did, thank you, only because I think it's a partnership waiting to be made. So I read in an NMSU press release, gosh, less than a week ago, that a new coordinator with the Northwestern New Mexico New Farmer Network had finally been hired. And he was able to join us for a little bit of the call. And I thought, just given the audience that this call was intended to serve, we would be remiss if we didn't offer an opportunity for him to say hello. So Wes, do you want to open up your mic and introduce yourself?
Yes. Can everybody hear me? I'm in my car. I just left a board meeting and scrambled to make this happen because I want to be a part of this. And I'll be really brief. Thank you, Katie, for giving me a small little platform. Born and raised in Mississippi and moved out, went to Appalachian State and got a degree in sustainable development, moved out here to Durango a couple years ago. And I've just been involved with about a dozen different nonprofits in various forms, whether it's consulting or program manager, administrative assistant. And so I really developed a heart for nonprofits and cooperatives. And I serve on a couple boards here, and just over the moon about this new opportunity with the new Farmer Network. I really feel like I have landed a dream job. And essentially, I am a matchmaker for new farmers and transitioning farmers and facilitating their lease agreements with the landowners. So there's various different ways where this land is going to come across the radar, whether it's an older farmer thinking about successional planning that doesn't have a family member that they can pass it down to, or whether it's a landowner who has, you know, a few dozen acres and they want it to be productive, or they just want to do a food share. So there's tons and tons of different ways that this can be adjusted. But essentially my role and what I'm really trying to focus on is developing relationships. Food is the foundation for a lot of cultures and a lot of relationships. And right now I am trying to develop as many strategic partnerships as possible. But it's, so the territory that I'll be serving with Bonnie Hopkins at the Ag Extension is San Juan County. And then as we start to build out and do program development, we'll move down to Shiprock and see about being able to facilitate lease agreements and getting new farmers the land that they need so that we can essentially put more food back into the local food system. That's kind of how this is oriented. And that's kind of what's going to take precedence is, and really just the priority is the land and the use of finding these agreements that are going to build out our local food system. So that's my goal. That's my mission. Thank you so much for letting me to say a couple words and introduce myself. And I'm sure I'll be getting to know a lot of y'all more and more as just as things unfold.
Thanks, Wes. Thanks for that quick introduction. Yeah, I'm just down the road from you in Durango, and I run the Southwest Climate Hub, so I have a feeling we have things to talk about. And for everybody on the call, our next call will be on, we're looking at September 23rd. And we sent a survey to you, so we really want to know what you would like to hear about. So if there's anything we missed, let us know, because we can structure that agenda around those topics for the next call. And with
actually, Emily, so the survey just went out to mentors, and yeah, and so sort of, you know, how we were thinking about today's call was sort of like laying the foundation to drought and aridity in the West. And the survey that was sent out to mentors is really trying to get a sense of how do all of our mentors manage through drought, and what tools are they using, and are there things that any of them would be willing to speak about, you know, through their lived experience, and also are there any tools or resources that they're also interested in learning about as well. So next time you talk with your mentors, you might nudge them and ask them if they've seen that survey, and also use it as an opportunity to to talk about what they've been doing if you haven't already.
Thanks, Leah. Actually, the best calls are listening to the producers. So I look forward to that one myself.